So to start off with, we'll be discussing the differentiation of inverse sine functions. So this is a standard integral formula that's going to be given to you on your standard integral chart, and that's given to you in all your exams. So we don't need to memorize this, but what I'd like to teach you today is how to use this standard integral formula for differentiation, and then also how to apply the various types of differentiation. So to start off with, what we're told is that the integration of 1 on square root a squared minus x squared equals to inverse sine x on a. So if we're told that the integration of this equals to that, then how can we use this to find out the differentiation? Well, if the integration tells us that this goes to that, then it just makes sense that the differentiation of inverse sine x on a must equal to that. Yeah? So if integration goes from there to there, then your differentiation should go from there to there. Does that make sense? Good. And now we just want to have a look at your general formula. So all we've done here is that instead of having x on a, what we have is x on 1. So essentially a equals to 1. And if a equals to 1, all I've done is substituted your a squared for 1 squared, which is just 1. So what we have is that the differentiation of just inverse sine x equals to 1 on just square root of 1 minus x squared. And this general formula for the differentiation of inverse sine x is going to be used throughout our questions. So all we need to learn from this is that from your basic integral formula here, we can use it for differentiation. All right, I'd like to take you through firstly the proof of why the differentiation of this equals to that, because I think sometimes it's hard to understand something if you don't understand why something is. So if you know the proof for it, I think it sticks a lot better in your head, and then when you apply it in questions, it makes a lot more sense. All right, so the first thing we want to do is let y equals to inverse sine x. And from our previous modules before, we know that this means x equals to sine y. So what we've done here is just switch the input and the output. And when we do that, exactly, we need to always switch the inverse sine to sine as well. Okay, so that's how we get to x equals to sine y. And now I'm going to differentiate in terms of y. So sine y differentiated becomes cos y. And this is dx on dy, yeah? Because we're differentiating in terms of y. But note that up here, what we want to find is dy on dx. Okay, so just keep that in mind. So I have dx on dy, but I want to find dy on dx. So what can I do? So I can flip it. So flip this, which means I need to flip that as well. And that becomes 1 on cos y. Now, somehow I have to make this cos y look like this denominator here. And how I'm going to do that is by using a trigonometric function here, which is that sine squared y plus cos squared y equals to 1. Yeah, do you remember that? Great. So if we know that this plus this equals to 1, we can rearrange that. So moving the sine squared to this side and square rooting both sides, I can say that cos y equals to this. Now, we look back to here and we see that we found that x actually equals to sine y, which means that instead of writing sine y squared, I can just substitute that for x. And that's how I get my denominator here. Yeah? So now I found this. I'm just going to substitute cos y for my square root down there, and that's how I've shown that the differentiation of inverse sine x equals to 1 on square root 1 minus x squared. So how we get this denominator here is by using your trigonometric formula here, okay? So I think that's really good to know. That's why we have a square root 1 minus x squared, because essentially we're using this up here. All right, So now that we know why this is, let's practice some questions and see how we actually use this formula. All right, let's start off with question 1. So a nice, easy question to get us started. Here we just want to differentiate y equals to inverse sine x, and it's using our standard integral formula that we've been given. So remember, we don't need to memorize this, but what I want you to know is how to get your differentiation formula from here. So this is integration, which means that the differentiation equals to this over here. And now we just need to substitute my a. So you can see here that it's x on 1, yeah? So a just equals to 1, which means instead of a, I write 1. So now I just have 1 on square root 1 minus x squared. And that's it. That's all you need to do for that answer, okay? So hopefully that is quite simple. So let's move on to something a little bit more difficult. So here we want to differentiate the inverse sine of x on 5, okay? And we've been very nice and we've given you the formula up here. So the first thing we do is think about what a equals to. So in this case, a equals to 5, doesn't it? Because it's x on 5, which means that instead of a squared, I substitute in 5 squared. And just always simplify and expand. So here, 5 squared, I just want to write my answer as 25 minus x squared, yeah? So it's quite simple, although initially it looks difficult because the equation itself is difficult. It's just normal differentiation, essentially. Okay, question 3, we want to differentiate y equals to inverse sine 3x. Now, this is slightly different because we have 3x there, which means we're going to have to apply the chain rule. So remember, with the chain rule, all we need to do is take this and find the derivative of that and multiply it, okay? So firstly, we just consider the inverse sine differentiation. So that's just using this formula. And now this time, I know that a equals to 1, and x here is 3x, that entire thing, yeah? So I have to substitute that entire thing into x. Does that make sense? So some students get confused because they just see x squared and they think, well, it's always going to be x, but you've got to know that this just stands for that whole thing, okay? So be really careful with that. So I've substituted that in, and now I apply the chain rule, which is here. I want to find the derivative of this. So now I just simplify. This becomes 9x squared, and the derivative of that is just going to be 3. So I can just multiply them together, and that's how we get our answer there. Okay. So the important thing to know from this question is when you have this input here, which is not just x, we need to apply the chain rule to it, okay? You really, really have to be careful with that. All right, let's move on to here. So question 4, we want to differentiate inverse sine of x squared. So once again, because this is not just x, it's x squared, you got to think straight away, okay, have to apply the chain rule. So firstly, let's just figure out the differentiation of my inverse sine. So a equals to 1, and x in this case is x squared, which means that we'll actually have x squared whole thing squared. Okay, and now I need to multiply it by the derivative of x squared. So this works out to be x to the power of 4. Whereas this, bring the 2 down, becomes 2x, multiply it together, and that's how we get it here. Okay, so I think the best way to do these questions is to firstly consider your inverse sine and then consider your chain rule and then put it together at the end, yeah? Great, let's have a look here. So question 5, I want you to differentiate x multiplied by inverse sine x. All right, so can you tell me what rule I have to use here? Yeah, exactly, I have to use a product rule, don't I? Because I have 2 separate x's. So remember, the product rule is just this. So all we need to do is take the derivative of the first one, multiply by the second one, plus the first one multiplied by the derivative of your second one. Now, I always write this line of working out. I think it's really important to not just jump into the answer, because especially with more difficult questions, it's just too easy to make a silly mistake and it's not worth it. Whereas as long as you have this, you're guaranteed to get at least half a mark because you're showing the examiner you know the process of it. And that's important in maths, to show the process, okay? So make sure you write out this step of working. All right, let's just work that out. The derivative of x is just going to be 1. So that just becomes inverse sine x. Now, the derivative of inverse sine x becomes this, yeah? Multiplied by x, that's how we get the x on top. And you always check if you can simplify anymore. And in this case, because they're so different, you can't, and that's going to be your answer. Yep. So it does look a little, usually it synthesizes together quite well, but don't worry, that is your final answer. Okay, well, what about working with e to the power of x? So here we want to differentiate inverse sine of e to the power of x. So because this isn't just x, we got to think, good, chain rule. Okay, firstly, let's find out the differentiation of the inverse sine. So instead of x, we have e to the power of x. Now, multiply by the derivative of e to the power of x. Now, I hope you remember that when you find the differentiation of e to the power of x, it just becomes, good, it stays itself, doesn't it? It just becomes e to the power of x. And similarly, if you integrate e to the power of x, it's just e to the power of x as well. So it's actually quite easy to remember. And here, because it's squared, it just becomes 2x. Okay, so you see how I'm exposing you to the variety of questions that we can come across in the differentiation of inverse sine? Okay, so question 7 here, I want to differentiate 1 on inverse sine x, okay? Now, forget about the fact that it's inverse sine. If I just had 1 on, like 3x squared or something like that, what would you want to do? That's right, we would just want to make that, change the denominator into to the power of -1. Yeah, that's what we always do. So don't get confused just because we're working with inverse sine here. So I've just changed this to -1, and because I'm differentiating this to the power of -1, I'm going to have to use a chain rule as well. So over here, I've just taken down -1 out here and subtracted 1 from this, so that becomes -2, multiplied by the derivative of the inside there, okay? Now, this is just going to become -1 on inverse sine x, the whole thing squared, yeah? Because that -2 makes it on the denominator here. And we know that the derivative of this equals 2, 1 on square root 1 minus x squared. And I've just multiplied that together and gotten this as our final answer. So you can see here, just remember that if you have a denominator, what you need to do is just do what you would normally do and make it to the power of -1, and don't forget to apply the chain rule for that as well.